My name is Jessica Webster, and this is my final video lab report on the physics of Angry Birds. My objective was to analyze and compare the projectile movement using Tracker and Python, and then calculate the maximum height of the bird's path. My summary is that the velocity x component is constant, and the velocity y component is changing with a constant acceleration. The gravitational force in Angry Birds is far different than that on Earth, and the maximum height is around 18.9 meters. Here's my tracker analysis on a great Angry Bird shot. My time interval starting once the sling was no longer in contact with the bird and ended at 9.93 seconds. The origin was where the bird started, with the bird moving in a positive XY direction. To calibrate the video, I used a realistic sling size of 30 centimeters and a large bird weight of 15 kilograms to try to make my findings more realistic. Although, a true Angry Bird mass would be about the mass of a big boulder. Cool, right? To properly analyze this video, I'll use the momentum principle to predict its movement. By it, I mean the Angry Bird. From this equation, I'll be able to find the maximum height of my Angry Bird's motion and be able to deduce basic information about the Angry Bird world. To compare my observed data to another model, I'm using this Python program to model a projectile motion using the position and velocity update equations based off the momentum principle. I initialize this code with the initial position and velocity from my tracker analysis. Also, I'm letting this loop last a little bit longer than my observed data to really see a pattern of my resulting graph. This is my resulting graph in my tracker analysis. On the graph, you'll see the movement along the x-axis in pink and the movement along the y-axis in blue. There's obviously no force in the x component and therefore a constant velocity given the straight line. As for the y movement, the velocity is always changing with a constant acceleration from the gravitational force. Clearly, there's no drag force in Angry Bird world. Also, note the approximate y max, 1.40 meters. Is this realistic? We'll see. Now for my predicted data using Python. The x movement in pink looks a lot lower than my previous tracker graph, but that's just relative. The max x values are actually the same at 1.70 meters. As for the y movement in blue, this goes a lot higher than my observed data. The projectile movement is still evident though. Why are the graphs different? I'll get to that in just 1 minute. To find the maximum height, the velocity must be 0, so I'll be using the velocity update equation to find this. Using a gravitational constant of 9.8 meters squared, I find the time to be 9.65 seconds. Using this time value, I plug it into the position update equation, and I find a maximum height to be 18.9 meters. So why were the graphs different in terms of the y component? My observed data is probably slightly off because of tracker technical errors. My predicted data is also a little off because of the longer time loop. But with the vast difference in the height of the graphs, the Angry Bird gravitational constant must be larger than 9.8 meters squared by a long shot. This makes sense though. If you have more of a force pushing you down, you won't go as high. My predicted model would be pretty accurate for a 15-kilogram bird given no air resistance though. I hope you enjoyed my lab.